started off as React in 0.14, and that's what was put on the meetup page. It's less of React in 14 and more of the second part, practices for building React applications. I realized going through this that there weren't a ton of things in 14 that I really wanted to talk about, while keeping this at like a more introductory level into like best practices in general in React, and starting from ground zero where there's like no preconceived idea of how much React anybody in the audience knows. So hopefully I can sprinkle in some deeper concepts for the people who already know a lot about React, while still like giving people who don't know much about React a good base to work from. And we will make a shout out or two to 0.14 specific changes. So we're going to go over in the talk is essentially what is React components and how like everything that corresponds to components, building an application specifically with Flux and how that fits in with React, and then finally talk over some patterns that are specific to React and how to make sure that your application follows good practices. So this is actually what quote you will find on React's actual landing page. They say that a lot of people like to call React the V in MVC. If you look in a couple other places, including React's Google group, there was like a conversation in 2014, middle of the year sometime, where somebody was like, actually React does a lot more than just the V. And somebody from React's core team came out and replied and was like, yeah, we just didn't want to scare people. We were already doing this weird thing with JSX, and we didn't want to tell people that we were doing controller stuff in your view and get everybody all freaked out. So there's actually been several people that quote it as React is actually the V and the C in MVC. If you don't know what MVC is, it's a pattern called model view controller, where essentially you have your data model, you have your view, which is, in this case, an HTML web page. And your controller handles taking input from the view, so user interaction, and then transforming that into some kind of command that modifies your data in the model layer. And so all that filters back through to the view. So React is really components all the way down. So this is like one of my favorite quotes ever. The story was all the way down. It's components, and then more components nested inside of components. And actually, that's one of React's core competencies is composition, is using components, composing components together to build an entire application. So specifically, the simplest component that you can have is actually just a pure render function. How terribly can you not read this in the back?
It's a little small.
It's a little small. I don't know.
You just print plus. Just kidding, sorry.
It actually works. It's really better. Somewhere in here. I might have to do that back and forth real nice. But so this is your simplest component. Aside, real quick, a lot of this is ES6 stuff. Like, and in general, even if it's not a question with ES6, please like break me and ask me a question if you don't understand something, because this is probably going to rapidly accelerate in pace, and I don't want you to miss something in the very beginning that I could probably have described better and then be off for the rest of the talk. So simplest component is one that purely just defines a render function. So here we're just returning, this is JSX, we'll talk about that in a second. We're just returning a span that contains the word hello. And then this is a React 14 nod, one of the precious few in my talk. React is now split in 14 between everything being in one React package to now there is a React package, a React DOM package, and inside of the React DOM package is actually React DOM server. So some of the top level API is now split to those different packages. The reasoning behind that is that React realized that it was actually not specific to the DOM. It was not specific to HTML. It was not specific to like web pages. And that's what React Native is. React Native is basically taking the idea of components, and instead of emitting HTML inside of render, we're going to emit iOS or Android specific code inside of render. So that's how that moves around. So this is the simplest. We're going to render this into a ID component. Normally that would be some div with just an ID of container, and then you shove this simplest component inside of there, and then render will be called by React. It will emit this span, and that will get put inside of your container element. So that is basically your simplest component. This is a nod to JSX and what it really means. At the top, we have a non-JSX component. So inside of render, instead of using the XML-like syntax, you can use the actual JavaScript syntax, and call react.createElement with a div, and then you would give it some. This here second parameter is just the props, which is just a map. And we'll talk about props, and then this would be children, and that's directly correlates to this div, which has an onClick as well, and this one's children, says my parents. Awesome, because it's JSX. So that's a pretty simple. If you don't understand JSX, please say something. All right, do that for me. This is where it's hard. So props. Components have two things, props and state. The first one being props. A simple component, props component, which has a render function, can reference this.props and take anything passed down in props. You'll see below we actually render the props component here in this example component, and we pass along props. So this.props.color will be the color code ACE, and this.props.text will be the string hello world. So one thing I don't think that I mentioned when we were looking at JSX is curly braces right here inside of this div tag. This is how you actually put JavaScript code inside of JSX. So you just run in curly braces. Another thing, this double curly braces is we're putting in JavaScript code, and the JavaScript code that we're putting in is an object. The other thing that you have in components is state, so props and state. And here we simply have a div that puts an onClick that uses this.setState. SetState is a React provided function, and it is the only way that you are allowed to modify your state. If you modify your state not using this.setState, React will get very angry at you and see a lot of errors. It says like you modified state outside of setState. I can't remember exactly. But essentially, setState merges this object that you give it into the actual state. So we initially start off with the count of 0 being state, and then every time that this div is clicked, we simply increment the state. So we get the current state and we add 1, and then we use the set state to actually make that take effect. And this triggers a re-render of your component. So React will, every time that props or state changes, re-render your component. It'll run through this again, and it sees where we have this.state.count. So that will be updated. It will realize that your component's returning different DOM, and it will update that in the actual DOM. I'm not really going to talk about the virtual DOM. That's kind of like a performance enhancement. So you can think of it as just wholesale. Simplest way of thinking of it is wholesale, just replacing everything, but it's a lot smarter than that. So these are what React gives you as basically its API. React has a very small surface area, which is why a lot of people really like it, because it's a very simple framework. It's not very, doesn't try and do everything for you. It just provides you a great way to do everything yourself. So these are the functions that you can actually use inside of your component to get hooks into what they call the rendering lifecycle. So before a component is actually mounted, when a parent component either renders this component inside of it and that parent component is being mounted, or if you're calling render React DOM.render to actually render a component into the DOM itself, then that component will be, the component will mount will be called for that component. Component did mount is actually slightly different in a very important way from component will mount, in that component will mount is called before anything is actually taking place in the DOM, so you will not actually see your component being rendered on the page. Component did mount is actually called after your component's DOM changes have been inserted into the DOM. And what that means is you cannot access what you're rendering for your component inside a component will mount because it's not on the page yet. So if you want to do any raw DOM manipulations on something that you're rendering, they're not there. So you will be trying to, React gives you a way to get them called refs, which we'll touch on later. You won't be able to get it because it's not in the page, so you have to wait until component did mount fires, and then you can get your things and attach. Like Google Maps is a great example. If you want to render Google Maps, you have to wait until your component container div that you use to inject Google Maps into is actually mounted on the page before you can tell Google Maps to render itself onto the page. Component will receive props is called before any props changes happen to your component. So if I'm rendering this component, I'm going to go back to props example. If I'm rendering this component, and then in this example component, I change something and I pass a different text down to props component will have a component will receive props fired, and it passes along the next props. The trick about component will receive props is that it's not called on the first render. So the first render cycle, your props come down, component will receive props is not going to be called. Should component update. This is something that you probably don't really need to worry about until you really need to worry about it. And it's basically performance-based. Should component update is called before React actually tries to re-render your component. And by default, it always returns true, so it's always going to re-render your component. You can intelligently check the next props and the next state versus your current props and state. And if you're smarter than React, you can say, I know that this component shouldn't be re-rendered because nothing that I care about has actually changed. You can return false, and it won't go any further. Component will update is actually called before a re-render. So it will be past the next props in the next state. If you return false from should component update, neither component will update nor component did update will actually be called. Component did update is called after the update actually takes place. It gets the previous props in state. One thing you want to watch out for is setting state inside of component did update. That will typically trigger a double render. So if the component updated and then you set state again, the component's going to do another render, and then you'll typically be doing 2 renders for something that you should probably only do 1. But that's kind of like a small thing. Component will unmount is finally the last thing that's called before the component is taken out of the DOM. Is where you can do a lot of your cleanup. In the case where you're using external JavaScript libraries that are fairly intelligent on React and you're doing raw DOM manipulation stuff, like adding event listeners onto the DOM and that kind of stuff, this is where you're going to want to clean all that up so you don't leak anything. Another note is that component will update and did update are just like component will receive props and that they're not called for the initial render cycle. So a lot of the times you will have to implement the same functionality in component will mount to get it called on the initial render cycle and then called whenever there's an update. Is everybody clear on lifecycle functions, where they fit in? Let's look at small aside, it doesn't really fit into the flow of the talk, but pure function components in React 14. So if your function doesn't need state at all, or if your component doesn't need state at all, then you can simply use a pure function that solely returns instead of the render. You can think of this as purely just a render function taken out of the S6 class style, and these are functionally equivalent. So we know enough to be dangerous, so let's go ahead and build something with just raw JavaScript and see what happens. So I actually already built this. I would like to start from, depending on how we're doing for time, start from a little bit more bare bones. So I have a new pen. So this is where you put your div with an ID of container. JavaScript. We're just gonna do Babel, quick add React, and then just change this to 14. All right, so now we should be able to actually render a component to the DOM.
I think you missed a dot.
I missed a dot. I'm saying in my that's all. So here I'm not actually using React DOM because I don't know how to include React DOM from that little bit, but if I look in the console, it'll probably be angry at me. So we're going to render a quick GitHub user followers thing. You'll see how few followers I have. So can we make it simple? In React 14, you actually have to, if you use the ES6 class syntax, you always have to extend React component. That's how they get pure functions to work. Yeah. Yeah. All right, so in render, we'll just do this real fast. I need to return statement. And then we'll just render the GitHub user component into the DOM. Hey, hello. So that's our component being rendered into the DOM. So I need to grab, nobody copy this because this is a personal key. Don't worry, it has no permissions. I'm not that dumb. Slightly, but it was on like a public anonymous pen, so I'm just hoping nobody stumbles on it. There's one other thing that I want to include here, and that's the script to get fetch. All right, so what we need to do, we have a GitHub user. We're going to accept the user that we want to render from props. So we'll just pass down here a user, and it'll just be my user. And then instead of rendering hello, we're going to actually render h1 with this.props.user to render my username. All right. So what we want to do is look into the lifecycle here. We want to get the actual users. We want to make a call to the API and get the actual users that follow me. So a great place to do that would be on component will mount. We're going to fire off this fetch call to the API. It's actually /users/ and then the actual user. When we get the actual users, we're going to need somewhere to put them. So we're going to put them in this application state. So initially, we'll fire get initial state, which is something I forgot to mention in lifecycle. There's two other functions. They're not necessarily lifecycle as functions. They're get initial state and get default props. And that allows you to do what they say, initially set your state before you actually call any set state. So right here, we're going to initially set state to
get initial state.
Return followers, an empty array of followers, which is not very many less than I actually have. And then in this here, we'll get followers back from the GitHub API call, and we'll call this .set state. We'll set the followers to be followers that I get back. So we need to render these followers into the page. So we'll actually make another component for this. This component's doing a lot. Make a GitHub, or just make a followers list component. And it's just going to take followers and props and render a UL with all the followers inside of it. So we need to, in JSX, we're going to map over all the followers that are provided to us and put them inside of an LI. So .props.followers. Is there anybody that doesn't know about arrow functions? This is simply a function. This is syntax right here. When we return li follower is directly equivalent to a function that is just an anonymous function that takes a follower and returns li follower like that. So these two things are equivalent.
Can you go over the class extends? That's just like syntactic sugar.
Sorry?
Class extends keywords.
Oh, okay. This is essentially equivalent to the normal way to do this in React would be react.create class.
Right. Okay.
And then you would pass a render function, and then you would pass a get initial state function. So that's the way you would do it before ES6 syntax. All right. So on render, we're going to render our followers and ULs. So here, to render followers, we'll just say GitHub. Can I just call this followers list?
Are your followers in props or state?
My followers here in this GitHub user component are being tracked in state, so that way I can keep track of them after I get them back from the API call. But when I list them, this followers list component just accepts them as props and then puts them inside of their lines. So we'll render the followers list with followers as props, and we'll pass along the followers that we are keeping track of in state. And theoretically, if I have any followers, I'll show up. Oh, I need to pass my access token, I feel like. Followers no. Followers.
Live coding.
Yeah, I know, right? Back over here. Followers. Whoa. That's weird. All right, well, I don't want to burn the rest of the time on this, so we'll just look at the finished example. See, at least I came prepared.
Pull that pile the other.
Yeah, so here we go. This is it done. This is 3 minutes later. Essentially, there's some stuff that I haven't gotten to yet, but this is our GitHub user component. It does the same thing where a component will mount. It fetches the user itself actually, and sets the user, and then it passes into. This is actually like a lot more advanced than where I got here. Followers list.
Have you returned the call map?
No, this should work correctly.
What's the arrow message?
Yeah.
Doesn't like map to things.
The error message is cannot read property followers of null.
Are you passing it in as a prop?
For this,
So that's not in your callback today.
Shouldn't we check this.props has followers? Because initially it doesn't.
but
Comes along.
Yeah. Oh yeah.
All right, what?
Yeah. If you're doing,
Well,
if you're doing it
we'll come back to this. There's more magic.
Developers.
All right, so
I think like
Phil's
half
building
of us are
something.
invested now, so you really have
The
to.
problem that yeah.
I have a question. When do you use like component will mount versus did mount?
So component will mount and did mount. The main difference is one of them has already been mounted into the DOM. What that means is if in component did mount you use set state, you'll trigger another render. In component will mount, nothing's in the DOM, so if you need what's in the DOM, you can't do what you need to do. But component will mount is a great place to fire off things that either in a component will mount, you make some asynchronous like call to get some data that's needed to render your component. You want to do that as quickly as you can, so you fire it off in the first thing that's going to trigger a render or going to trigger in lifecycle. All right, so after that failure, we'll go back to our regularly scheduled programming. The reason that failed is because we weren't using Flux. No. But if you look at render at a higher level, it can be thought of as a pure function of props and state. So what that means is a pure function is something where every time you give it a set of inputs, it always returns the same output. And it's another word for that is deterministic, referentially transparent, all these other fancy things to say the same thing, which is just that given the same props and state, we're always going to get out of that component the same view. And this makes it easy to reason about what a component is doing. We can give it any permutation of props and state, and we can expect to see the same view back. So there's nothing like magical happening where we can't reproduce some bug because there's some like other component somewhere else that's touching something in this component and it's rendering differently 3/4 of the time. If you give it the same props and state, you want your component to render the exact same thing to the DOM. So what if we take a step back and think about doing that same thing for the entire application? So our entire application state is what is needed to render the entirety of the application. What if we consider the application as a pure function of one massive state tree that gives you back the same application view every time? And that's a very high level, probably imperfect way of describing what Flux is. In this talk, we're going to look at Flux really quickly. We're going to use Redux. It's not the only Flux framework. It's just a very widely popular and well-documented one. That's why I've chosen it. So I don't want anybody who uses something else and hates Redux to like, get out their pitchforks. The principles of Flux are that there's a single source of truth. That single application state you can think of at the top, flowing down through your application, is the single source of truth. Anything in that application state is what's going to be rendered on the page. Nothing else should be able to change that without it being reflected in the very top actual state. Actions are the only way in Flux to change state. So if you mutate that state in any way, it should always be done through firing an action. This is easier to see in a picture in a second. Mutations are pure functions. This is one that's almost more Redux specific than some of the other ones, but it can be, in the case of Redux, if you're not familiar, there's this concept of reducers. Your reducers should be pure functions. I'm not going to get into too much of it. In the case of regular Flux, the store dispatches changes. Those dispatches to the store should always, if you dispatch like some user to a store, it should always add that same user to the state of the store. We'll get a picture to make that more evident. But the last thing is that there's unidirectional data flow, which is basically the same concept of having your state all at the top. What's in that state flows down through all of your React components. They all render the same thing, so they're all given the same state, either through props or whatnot. And then you always see the same thing given the same state. So it becomes easy to say, here's my state. You know what I see because you see everything in the application in that one state. So here's what this looks like in the Flux diagram on the reference implementation from Facebook page. Their implementation says that there are these views, which will be our React components that render the view. Whenever a user interacts with the view, it fires an action up to this dispatcher. This dispatcher updates some stores based on that action, and then the stores data is passed back down to the view, to your components through props, and then your components re-render based on the different application state. There's also this other action over here, which is basically saying that actions don't only have to be triggered by user interaction or by the view itself. It can be triggered by, like, if you want to poll for updates, you can set some timeout or interval and constantly trigger some action to poll for data from the server. This is a simplified Flux and kind of demonstration, which is that, like, ignore the fact that there are stores and dispatchers and actions and all this crazy stuff, and just think of it like this. We have one central store, ignore the word store, we have one central blob of data. This is our central blob of data. We pass it down through a component hierarchy, which is our components from React. They all render the same thing and just pass more of this data around. There's no dependencies in between the interdependencies, intermingled things. They all render the same thing given the same data. And then anytime that they do something, they update this central data, and then that data comes back down, and then it's re-rendered, and the changes all show up, and it's all magic. This is a Flux version of the failed demonstration earlier. And apparently doesn't like to be zoomed in very much. We have our GitHub followers. On the component we'll mount, we dispatch some action, some Flux action. It says load the followers. And then we render followers that are passed down to us through props in the same way that we tried to do earlier. This right here, these are all not in the same file, just as a quick FYI. Like these are normally distributed across the application. This is just to get them all in the same spot so we can look at them all at one time. This should show, basically, this is the components where we're being passed some data and props, and then whenever something happens in the view layer, we fire an action. We connect this component, and this is just a specific way of saying that this component wants to be passed followers and props. Whenever followers changes in like the top level view, that'll be resent down as props, and this component will be re-rendered. So we have a load followers action. This is what's called an action creator in the Flux world. All your actions should be created by these functions which return an action, and that's just to make it easier to do like actions.load followers whenever you need to load followers, as opposed to returning this weird object that you have to remember the structure of every time. So this is just going to fire an action, and an action is simply an object with a type and then some data associated with that object. So the type in this case would be we've received followers, and they're hard-coded in this example. The followers are just going to be Lisa, John, Tim, and Amanda. These followers would be normally retrieved from some API call or from your server or some data source, and in load followers, and then they would trigger this action with the results. Finally, you have a reducer, which is essentially Flux's or Redux's way of doing Flux stores, which is whenever this action is triggered, it goes through the reducer, and the reducer looks, and if this reducer is purely considered with or concerned with followers, and it says whenever the action received followers is sent, I'm going to modify the large application state of everything, and I'm going to change followers from whatever they used to be to just whatever is passed in action on followers. So essentially what this looks like is this component mounts, it fires load followers. Load followers down here returns this action, and the reason that this is surrounded in dispatch is because that's Redux's way of saying whatever's returned from load followers, I want you to send it through all of my reducers. So this action right here is then sent through all the reducers, one of which is followers. And we say, oh, we care about that action. We want to change whatever followers to whatever followers are passed in the received followers action. And then that finally comes back up here where we say, in the state, we care about whatever followers there are. We want them passed to us as the followers prop. And that's how followers gets all the way back to the component at the very top. So hopefully that was reasonable. Now for my much more ambitious demo, a Twitter clone. Luckily, I did the same thing in this case where I already did most of it. So in the case of drastic explosions. This is kind of a really high-level, full-featured overview of an application. So first things first, a router. This does client-side routing in React. The most popular, I think, by far one is React Router. So this is simply, we're going to define some routes. So if you render, show this in view. So right now I'm at /login. So with the path /login, I'm going to render the login component. With any other path, I'm going to render the dashboard component. And when you go to the root path, if I just go to this, then it redirects to login. So that's simply what this says. These on-enter things right here are just a React Router specific way of saying if a user comes to the login path, if they are not, or if they already are logged in, then redirect them to dashboard. If they aren't logged in, when they try and go to the dashboard, redirect them to login. So it's just a way of making sure they're authorized. I'm not going to show the implementation of that because it's not really React or Redux or anything. This is essentially the login component. So we're purely focused on the auth form of, or the auth portion of this page. The login component renders just 2 text fields, which are right here. Instead of using input, I'm using text fields. This all comes from Material UI, which is a library to make it to where my demo doesn't look like complete crap.
I can't see any of your actual variable names in this slide. The red is like just, that's all right. That's a hard color to read.
All right, I apologize.
It's all right.
So we simply have 2 text fields. We talk about all these other things right here, like where the state's coming from and what this on email change is. And then we have 2 buttons, both of them on click. They do 2 different actions, and we'll look at those actions. So this is all still in the same component. It's just not shown all in one view because you can barely read it even with this view amount on one page. But inside of login, we set the initial state. This constructor here is equivalent to like an initial state with some other stuff. This state is setting the initial state of this component. The password and the email are empty strings at this point. We passed to these 2 text fields these on password change and on email change functions. Both of these simply set the state of the component based on what you're typing in the input field. So when you type in the field, my email, that's just simply being set into the state and then passed back down to these input fields as the value of the input field. So when you type a character, it fires the on change. My component's resetting my state and passing that, what you just typed in, back down to the text fields to display. And finally, the on register and on login buttons, which is where the meat of the action takes place. So that is the thing that's passed to the on click of both of these buttons, on register and on login. So this is where your Flux actions come into place. We finally got the user interaction that we care about. They click this login button. What we want to do is actually dispatch a login action with the current email and password. If they click register, we want to do the exact same thing, fire off a register action. And what does that look like? These are our action creators, which is exactly what these functions are right here, register and login. Both of those do almost the exact same thing. So we're using this helper function, which is essentially in itself returning a function that uses dispatch. This is a way you can do asynchronous actions in Flux. So what I said earlier, where an action is simply a object with a type and some related data, you can Redux itself lets you, instead of returning just that simple object, you can return a function that expects to be passed into it as parameters to the function dispatch, which allows you to send off this asynchronous request. This is some promise that I get passed in, this auth login and this auth register both return promises. So given a promise, I want to wait until that promise actually fulfills before I dispatch anything, because otherwise I don't actually have the value of the user. So I return a function. This is just called for me. It's passed in and dispatch again. And then I can dispatch the simple object whenever a successful login happens. So when a successful login happens, this promise is called, and I dispatch a login action with the current user. And I also dispatch another action. This route to action is, I don't think I have it in my slides right here. I can show it to you in code. It simply immediately dispatches an action of type route to, and then a parameter of what the route is. So this is I'm going to route to the dashboard, and that simply handles the client-side routing through the React router. So whenever the user logs in, I say, hey, the logged in action happens, and I also want to route to the dashboard. So the dashboard itself is hopefully what we'll look at in pieces right now. I have, let's see. So here's where you log in. And this is what we're going to be creating, essentially. You log in, and actually you can log into this right now. You go to this 10.50.9.50 port 8008 if somebody would log into it, we can just demo what the application should be doing. You log in, it's basically take Twitter. I'm sure you've seen the same demo before. Shout whatever. We can shout something. We can basically tweet something. There we go. Nice. So we've got yo from John, and, Josh. And so that's all being done for us. So how does that actually work is the question. And let's go look at some code. So, is that big enough?
A little bigger.
A little bigger.
Is that big enough? Okay. So we're in the dashboard. I'm just gonna look at the code. I don't think we have enough time to like actually try and code it out. And a component will mount. We're gonna dispatch an action for fetching shouts. So what this says is like when this dashboard is actually gonna be mounted on the page, we need the shouts from the database to actually render. Otherwise, the page is going to be empty and it's going to be rather boring. And then we're also going to set an interval and dispatch the same fetch shouts action every 1,000 milliseconds, which is basically just polling every second. We're going to fire off this action. So that's how when Josh said, yo, I actually saw it without refreshing that page at all. And then this is a great example of what component will unmount should do for you. I set up this set interval. I need to actually make sure that I clean up after myself. So the component will unmount. I can grab this _poll that I set on this object and make sure I clear the interval. Finally, the render, which is actually pretty small. This is just that application bar at the top. Doesn't really matter. The one thing that is of note here is that there's a button in the top right to log out. And what this does is, if you can see a pattern here, when somebody clicks that button, it dispatches a logout action. So I have a shout input, which would be this input field here. We can look at that component in a second. And then there's a shouts component, which is simply this entire component here that actually gets passed into shouts. So what we're going to look at is how the shouts actually get filtered through the system. So right here, I'm accessing this .props.shouts. But like, how did that even happen? Like, where did I even get shouts? If you'll remember, this dashboard is actually rendered for us by React Router. So when we go to the dashboard path, it renders dashboard, but there's no shouts here. Shouts are actually being handled for us by Redux itself. So in the dashboard component at the very end, there's this connect call happening. This connect call is simply a way of saying, given the entire application state, what does this component actually care about receiving? And the way you specify that, and this is Redux specific, the way you specify that is you pass a function that takes the entire application state and returns an object of just the things you care about. And the keys of this object are what's going to be given to you in this .props. They're going to be passed down to your component as props. And the value here is the corresponding value in the global application state. So we're getting shouts from the global Redux application state. And the question is, where those shouts actually get put into the global application state. When this component's mounted, we fire fetch shouts, and we're constantly firing fetch shouts every 1 second. So it's probably a good bet that fetch shouts is actually what's responsible for giving us shouts. So if we look at what fetch shouts actually does, it does the exact same thing that our login actually does, where it returns a function. This is the same as saying return function dispatch. All right, so we're expecting Redux to call this function for us and pass in a dispatch method. That dispatch method is what we can then use to dispatch actual actions, which are simply objects with a type. So what we're doing is, this is parse, which is a simple like backend as a service, like API as a service type thing. We're basically saying, give me all the parse, or give me all the shouts from my database. Parse is my database. Order them, and then whenever I actually receive the shouts, this is an asynchronous call to Parse's API. Whenever I actually receive the shouts, I'm going to dispatch an action using the dispatch method passed to me. It says, hey, I've received shouts. here are the actual shouts. So I'm going to map over the shouts that were given in the results and create like a small object that has a shout and an author, and that's why you see like the actual text, and then the author is the email of the person who texted it. Finally, I don't handle errors at all, so there's no error handling in this. I just log out errors right now. Theoretically, when you get an error, you would dispatch some other action that said there was an error, and then you could present that to your user in your components. So this is how we get shouts back through. Finally, the last piece of that is the reducer. So when this dispatch actually happens, that's then passed through all of the Redux reducers. This would be the same as in normal Flux. If you dispatch an action, that gets passed through to your stores, and your stores actually like listen to an action, and then when that action happens, they modify their store state. So let's look at the shouts reducer. The global application state, it's worth noting for this, is I have a shouts reducer, I have a user reducer. So in this dashboard, we're not registering for the global application state. The global application state is simply an object that has shouts that's some array, and it has a user that's like some opaque object. So that's why like I'm doing state.user and state.shouts, because that's what my reducers have registered their actual values as in this global state object. So I just want to make sure I make that clear, because some of that is hidden from you in like Redux specific functionality. So here we have the shouts component. So this is the exact component that makes it available, shouts, and then we have the other stuff. This shouts right here is exactly what's responsible for making sure that in the global application state, the key for this value of state is actually shouts, and then this initial state right here is where that initially is an empty array. And then in Redux, your reducers are simply a function that takes state and action and return the next state. So you have the entire shouts. This is not the entire state. This is just the shouts portion of the state, just the tiny little array portion. And you're given that, and you're given some action, and you're asked, given this action, what do the shouts look like after this happens? So if I only care about if I received a shout, this shouted thing is how we actually shout, which we can look at in a second. But if I receive a shout, I want to just return exactly what was dispatched as shouts. So exactly what was in this array right here. I got dispatched in this action. I check that that action is like the one I care about, receive shouts, and then I say, instead of an empty array, the shouts portion of state is now whatever was returned from, in this case, parse. In another case, I could dispatch this action from anywhere else and pass in some shouts from any other service or anything, and that action would be listened to by this store, and it would say, oh, I've got new shouts, and it would replace the old shouts with the new shouts, and then you would automatically see the new shouts being passed to you here. So that's finally completes the circle. From the component firing the action actually, I should say the component like calling an action creator, that action then gets dispatched through the reducers, which modify the global application state, and then get filtered back down to your components because they said, hey, give me these particular portions of the application state as props. That I get a lot of talking, and there's like silence. I take that as hopefully a good sign.
You've been fluxed. Successfully fluxed.
Does anybody is anybody missing a spot in this cycle? Like where everything hooks together? Is there any particular piece that's more confusing than the other pieces?
The connect part.
Yes.
How does it work? Can you?
Okay, so the connect is Redux specific. So I have this global Redux state. You can think of my entire application being some object with shouts and then some user object. And what I'm saying here is this is my dashboard component. Same one I used up here. What I'm saying here is that I want the entire state right here. This is my state object. I only care about user and shouts keys. I can name these keys anything. I could name this like Bob and Tim, right? What really what really matters is this part right here where I'm saying that like this is the key that I expect, this is what I want to be passed down as props to the dashboard component. So when I say this.props.shout in the dashboard component, this is that. So if I renamed this to like tweets, then this right here would change to tweets. But it still is like behind the scenes hooked up to the actual global application state from Redux as shouts. So I'm basically saying I want user and tweets passed to the dashboard component as props. And the way that works is whenever the dispatch fires and the action goes through and your reducers change the global application state, then the props that are passed down to my dashboard component are now going to have changed. I will get new props, and that's what triggers your re-render. Whenever you receive new props, or whenever your state changes in a React component, it triggers a re-render. And so that's what's triggering this component to actually re-render itself with the new shouts. So this was going to be the way to do it, but it's getting pretty late, I think. So we're just going to go over quickly like some basic patterns. When to use state is a common question with React, and the answer is, and when I say state, I don't mean the Redux state or your Flux state. I mean this .set state inside of a component. The answer to that is usually you want to avoid state wherever possible. Keep your components stateless. A cool side effect from that is you get to use those awesome stateless function components in Node.14. Real reasons behind that are that it becomes more easy to reason about your components when your components aren't doing things that you didn't tell it to do. It also makes your components more easily reusable across your application. And if you try and modify state a lot in a component, your component usually gets to be something that's doing too much or doing something too specific to where you placed it. Whereas if you pass everything down as props, it's easy to take that component and put it anywhere else in your application and just modify what props you're passing down to it to fit the need for that component anywhere else in your application. Performance-wise, there's not a super great reason why you should avoid state, except for potentially in the future they can make performance optimizations based off components that don't use state, with the whole goal of like moving to, I don't want to say the whole goal, but one of the goals of moving to pure function components that are purely based on your props and no state is that enables some further optimizations going in the future that we'll see if that actually happens. So an anti-pattern that a lot of people that are new to React do, I definitely did this a few times, is computed values based on props. That's basically where it's saying that inside, oh yes?
Sorry, quick question. What's, having fiddled around with React a little bit, what's the relationship between the pure function components and I think it's like the pure component mixin?
Yeah, it's actually a pretty good question. Pure render mixin is what I think it was called before. So pure render mixin is basically a way of saying it overrides should component update, and it checks to make sure on every should component update that your props or state have actually changed. So it does like a deep quality check of props and state. I'm not sure how deep. Somebody can correct me on that. They actually know. Pretty sure it's not deep.
It's very shallow.
Okay, it's very shallow. Okay, so it's a very shallow check to see if any of your props and state have changed. So that's potentially dangerous if you have like deep structures. But basically, it's a way of short-circuiting like a re-render. If like it looks like your props and state are the same, and you're only using like if your render function only renders what's in props and state, it's pure based off of props and state, doesn't do anything fancy, then you can short circuit a lot of renders if your props haven't changed.
Gotcha.
How do you use mixins in the new syntax? Like
So in class syntax, you can't use mixins. That's the short answer. The long answer is they took out mixins, and then they were like, oops, we probably shouldn't have taken out mixins because we weren't ready to take out mixins. When he says mixins, mixins are a React way of basically plugging in. You can have a mixin that overrides, I shouldn't say overrides, it implements should component update, or the pure render mixin is one. It implements should component update for you, and then inside of your component you say, ooh, I want to use this pure render mixin, and then whenever should component update is called for your component, it also calls your mixin should component update, and then it kind of intelligently merges the results. A lot of the talk moving forward is that mixins shouldn't be used, and they're kind of an anti-pattern. Dan Abramov, who's the creator of Redux, has a blog post about, I think it's titled "Mixins Are Dead, Long Live Composition" or something like that, which talks about how to use higher order components, which is essentially decorators in ES7, or just like think of it purely as a function that takes a component that returns another component. And what you do is you basically wrap components in other components that achieve that same functionality that you would get from mixins. Yeah.
I was just going to say, connect is an example, right?
Yeah, exactly. Connect is actually a higher order component that wraps your component in this thing that manages passing the application state down into your components as props. Great example.
So, so the current stage, we don't have ES7, we don't have decorators. Can we still use the
yeah, the decorators are simply sugar, syntactic sugar. It's purely a function that accepts a parameter that returns a component. You have a question?
Yeah, more like management. I think a lot of people like React because they trust Facebook to make practical, good decisions going forward. They'll be here in like 2 to 5 years, and they'll be generally the same library. I'm wondering about trusting Redux and other like third-party frameworks.
That's a great
If you
question.
feel like
Redux was
technical
actually,
debt or anything like that.
Yeah, sorry?
We didn't get a question back here.
Oh yeah, he asked, you trust Facebook to keep up with React and like make good decisions about like implementing React, but Redux is like really new, and who knows if it's going to be around in like a month. It came out of nowhere, and that's just, I think Flux is really new, and that's why I like kind of prefaced my choice of Redux for this talk as like kind of just an easy one to pick. It came onto the scene, it blew everything else away really, took over in popularity like overnight essentially. Before that, a lot of people were using Alt and Flummox, and some people still use like Reflux. Flummox actually like deprecated itself, and like the core designer went on to like work on Redux a little bit. But I don't know if I really have an answer. Like, this stuff is all moving so fast. Like, this is a huge paradigm shift. The guy who wrote Redux now works at Facebook. He's not going to be writing Redux, I don't think. He's going to be working on.
I was saying the thing that you can accomplish everything Redux is doing, for the most part, with just using React, just using stores and passing functions down to props. So that's another reason why I wouldn't be too hesitant to take it up, because the footprint that it has on your application is so small. It's basically saying it's actually performing as a module should.
Exactly. The Redux, I think, when you take out some of the like sugar and a few of the like warnings and stuff, essentially, I think it comes down to like 100 to 200 lines of code.
Oh, okay.
Yeah, it's a very simple library. So if it comes down to it, thing is, it's not doing so much for you that you can't just do it yourself.
Right. Okay.
There's not any other immediate questions. I think I have like another slide. Oh, I was going to say that computer value is based on props. This is just that in your render, if you're taking, or if you're tracking in state, sorry, like whenever you receive state, say you're getting a first name and a last name is a good example. If you're tracking in state like full name, and whenever you receive props, you like reset the state to track like this.props.first name plus this.props.last name. That's an anti-pattern. If there's anything that you're tracking in state that can be computed solely based off of your props, then you should not be tracking in your state, and you should simply just compute it based off the props every time in render, or make a small helper function that computes it and call that helper function from render. And another pretty good rule to follow is don't store data in state that you don't own. So if you aren't the creator of this data, it's probably a good bet that that data should be passed down to you by the person who owns it, or be given to you, because you shouldn't be tracking like data that you're not responsible for.
The general rule is the state should be as high as up the component tree as possible. Right.
Yeah. And that's something that like Flux really, like your state is at the very top and pass down through everything. So one thing that I use state for more frequently than anything else, and it's pretty much the sole thing that I ever use state for, is presentation values. So simply like, is this hovered, or something along the lines of, is a drop-down visible, like toggle a drop-down on and off. Stuff that you don't want to survive like a route transition. If somebody like triggers a client-side route, goes to a different, like renders some different components, and then hits the back button and comes back to your page, do you expect that drop-down to save the fact that it was toggled down? Like most of the time, you don't. And that's stuff that can't survive on mount and a remount, and presentation-based stuff is specifically some stuff that's good to keep track of in state, in my opinion. Smart and dumb components is something that's been like talked about a lot, and this is the same concept as basically controlling your state as high up in the tree as you can go. It's also the concept of not conflicting what is considered the view and the controller. So we talked about the V and the C in MVC. Your view components should be rendering your DOM and your presentation of that DOM. And your controller components should be the one that are responsible for talking to third-party APIs, or if you're using Flux, triggering Flux actions and registering the Flux stores essentially and getting that Flux data. But they shouldn't then be responsible for also presenting that. They should probably talk to a dumb component. So those would be smart components. They're talking to APIs. They're aware of Flux stores and state. They're containing some business logic, controller logic. Then they should pass that along as props into what are considered dumb components that have essentially no dependencies on the rest of the app. So they don't know about Flux stores. They don't know how to retrieve any data that they might need. They expect purely all that data to be provided to them, and they're solely responsible for putting that data onto the page in like a particular presentation. Let's see.
For the DOM component, would you expect to dispatch events?
So typically, when you have a dumb component, you wouldn't know necessarily about events. Your dumb component would accept callbacks through props and would just call back that action. Whether or not that's firing a Flux action or doing something else is a detail of the smart component. But your dumb component, say a button, it doesn't know to trigger on, like whenever it's clicked to trigger some Flux action. It accepts a prop that's on click. And then whenever that's fired, it just knows to call the on-click prop. And then if the parent provides it, they can provide whatever they want to call. If they want to dispatch an action, or if they want to do something else. Or if they're not using Flux and they want to just do regular stuff, that's up to the parent. And that definitely encourages and makes it easier to reuse components across your application when all of that configuration is being passed down from parents. If your component is aware of Flux, sometimes it's hard to move that to also use that component somewhere else in your application. The reason being that it's updating state that you might want to be different. So if you've got like an autocomplete box on one side of the page, and you've got an autocomplete box on the other side of the page, if you manage the results from the autocomplete inside of Flux and you keep that inside that component itself, you can't put that same component on the same page, because when you type in one autocomplete box, it's going to autocomplete some stuff, it's going to dispatch that action to the store, it's going to overwrite the data that was autocompleted from the other box. So if you instead make your autocomplete box simply accept the results that it's supposed to show, and then your parent who renders it is responsible for either storing that data in a Flux store or storing that data in its state. Then it becomes reusable across the application. There any other questions? Yeah.
How do you think about relay in the landscape of this like Redux, Flux, React?
Yeah, so I only used Relay a little bit. He asked how I feel about Relay. Relay is Facebook's, what's the word for it? It's basically a way for inside your component declares what data it needs, and then Relay will collect that query and make one query to the server to get all the data, and then automatically give that data to your components for you. So instead of dispatching actions, you just say in your component, I need the shouts from whoever, right? And then Relay automatically knows where to get the shouts, and then it automatically gives those shouts back when it receives them. It's pretty cool. I think Relay specifically is really too tied to GraphQL right now to be usable for a lot of people. GraphQL being the language the query language that they made, and it's like an entire, you have your server has to know about GraphQL and handle GraphQL queries and return GraphQL responses to work with Relay. I think when that becomes abstracted away from just being usable inside of GraphQL or something like Falcor, which I haven't looked at, could be pretty powerful. But I think that Redux is, like we said earlier, such a small wrapper, and it achieves what it sets out to do like very well, that it's a pretty safe bet to move forward. I feel like it definitely helps me reason about my application better. So I think it's a safer step than jumping all in with like Relay. Yeah.
In your Twitter clone, did you have favorites or likes?
No, I did not. I actually had hearts. No,
Okay.
I didn't implement any of that. But if I did, it would probably have been some like star heart amorphous block.
Right.
And, I think that would really drive user interaction. Yeah.
Is React Flex a way to have subordinate routers kind of handle and encapsulate actions at a lower level, or is it all at the application level?
Subordinate routers. Can you try and
To have like something like more encapsulated UI that knows how to kind of represent states in the router and be able to kind of invoke.
I like that idea. Like it's that your level of encapsulation of like where you're getting your source routes from. Like you need some sort of compositional model to spread from somewhere. Like you can start thinking about where these other provided nested routes would be sourced from.
Right.
So an interesting thing, I don't know if this is where you're going with it. I think this is what you're trying to ask, is basically those on-enter hooks that I put on React Router. There's on-enter and on-update hooks that you can put into your routes that are essentially functions that are triggered whenever that router is like entered or like re-entered. So I've thought about putting at the fetch shouts action. I know that I need to fetch shouts whenever I'm on the dashboard. So you could put that inside the dashboard on enter in the router, and it knows to like fire this action and this action to fetch the data it needs to actually route to that place. But to me, it seems, at least in that iteration, like in that form, it seems like the router shouldn't really know that it needs that stuff. It's really the component that knows that it needs that stuff, which is why I still prefer to put that in componentable mount. I like to think of it as like my component knows that it's trying to render shouts, like it's got a shouts component inside of it, and it's passing shouts down to somebody. So it's the one that really knows that it needs to get those. So that's why I handle that in componentable mount. It would be interesting to see a more like if that could be tied together with the router like more intimately though. All right, well, thank you. I am at Fort Truth, basically anywhere that matters, which is GitHub, and I don't really tweet very often because I just don't. I work at Social Tables. There's several Social Tables people in the room. If you like programming and like what I just talked about, and like React, then come talk to me. We're always looking for new, intelligent people. So thank you for your time.